So negative 3 is in the first position, so we call it the first term. You can call it T1 because it is in position 1. 2 is our second term, so we call it T2. 7 is our third term, we call it T3. 12 is our fourth term, and we call it T4. In grade 9, this is the method we use. We ask ourselves what is in position 1 and what is in position 2, what is in position 3, position 4, and so on. So in this case, negative 3 is in position 1, 2 is in position 2, 7 is in position 3, 12 is in position 4, and so on. Then we ask ourselves, if we continue counting like that, what then will be in position n? And that is what we mean by Tn, and Tn is called the general term. So this is our general term or the general formula. Okay, you can call it the nth term. So the general term is the nth term. Tn can be given in terms of position, and the constant difference. So let's talk about the constant difference. These two numbers here, negative 3 and 2, what is the difference between them? It's a 5. So we keep on adding a 5, so the difference will be a 5. And you will notice to get 5, you say 2 subtract negative 3. Same here, 7 subtract 2 will give you 5. Same there, 12 subtract 7 will give you 5. So in our case, the difference is equal to 5. Then you are trying to find Tn using the difference and the position. So if you look at T1, T1 is negative 3. So if you take the position, so this is what we will be doing. We will take the position, multiply it by the difference, and then add or subtract something in order for us to get the term. Like take the position 1. If you take 1 and you multiply by 5, you don't get a minus 3, right? So 1 times 5 is 5. So what do you do in order to get a negative 3? All right, so T1 is 1 multiplied by 5. What did you say? You need to subtract 8, right? Okay, now let's see whether this pattern is the same for T2. So for T2, if you take 2, which is the position, and multiply by 5, which is the difference, what do you get? You get 10. You don't get 2, right? And what do you need to do to get a 2? You need to minus an 8. Okay, maybe one last one. The position of, obviously, T3 is in the third position. So if you take 3 and you multiply by 5, you get 15. So 3 multiplied by 5 is 15, but 15 is not equal to 7. So we need to subtract an 8. And so already we can see a pattern, right? So if things continue like this, we will have to think exactly the same way for T4, think the same way for T5, and so on. So we need to also think the same way for Tn. So to get Tn, we take the position, which is n, multiply it by the difference, which is 5, and then we need to subtract 8, which is why Tn is equal to 5n minus 8. All right? Do you know a formula for finding Tn? Let's try this. So the first term is called T1. I want us to call it or to refer to the first term as A. That is what we shall be doing in number patterns. We will normally use the letter A for T1. So instead of writing T1, we can just write A. But what is T1 in our case? It's a negative 3, right? So I want you to tell me, how do I get T2 using T1? So I take my T1, right? And what do I add? And then I add a 5. Okay, 5 is called the constant difference, right? Okay, what about T2? Sorry, T3. How do I get T3 using T1? I start with T1, which is minus 3, and what do I add? Do I add a 5? How many 5s do I add? So I add 2 5s, right? And this should give us 7, right? Right, I want us to get T4. We start from negative 3, and what do we add? This time we add how many 5s? We add 3 5s. And so same story for Tn, start with a negative 3, and what must we add? If you look up here, for T1, we are actually adding no 5s, right? But for T2, we are adding only a single 5, right? For T3, we are adding 2 of them. For T4, we're adding 3 of them. Therefore, for Tn, how many are we going to add? N minus 1, right? N minus 1 5s, which you can rearrange, obviously, and write as minus 3 plus 5 into n minus 1. If you simplify that, I'll simplify and rearrange. I'll get 5n. If I remove those brackets, I'll get 5n there, minus 5 minus 3, which will give us 5n, subtract 8. Right. So I want us to generalize now. Let's suppose our first term is A. The constant difference, let's call it D. So the constant difference is the number that we keep on adding to get the next term. So if we start with A, then what is the next one? What is the next term after A? We need to add a D, right? And what do we get? A plus D. Now, to get the next one, you need to add another D, just like we were adding a 5 in the previous example. So now add another D here. So what do you get now? Now you get A plus 2D. Right, to get your fourth term, you need to add D to this one here. And so you get A plus 3D. Do you see the pattern? Now continue like that and tell me what you must add, or rather what you should get for the nth term. Because this is the first term, this is the second term, this is the third term, this is the fourth term. I want us to think about the nth term now, Tn. You will notice that the number of D's that you are adding to get T1 is 0. So T1 is equal to A, which means we are adding no difference. But T2 is equal to A, and we need to add 1 difference. T3 is equal to A, but we need to add 2 differences, and so on. T4 is equal to A plus 3 differences, and that is why Tn is equal to A plus how many differences? N minus 1 differences. So this is another very important formula for finding the general term of a linear number pattern. Right, can we look at one example together? Let's build a linear pattern together. I want our linear pattern to start with a negative 10, and I want us to generate our terms by adding a negative 3. What are we adding? We are adding a negative 3, right? So let's add a negative 3 to the negative 10. What do we get? We get negative 13. Let's add another negative 3. What do we get? Negative 16. Add another negative 3. What do we get? Negative 19. Right, so it's a number pattern. If I give you the first 3 terms, that should be enough to tell you what the number pattern is. So what is A in this case? Negative 10. And what is D in this case? It's negative 3. And how do I get D? To work out D, tell me, what do I subtract from Tn in order to get D? We should subtract Tn minus 1. Okay, so that is kind of the general formula for working out D. So to work out your constant difference, you need to take a term and subtract the previous term. Right, it will be a constant difference if you are getting the same answers throughout. So in our example, we have a minus 10 and a minus 13 and a minus 16 and a minus 19 and so on and so on. Initially, you won't know that this is a linear pattern until you work out the differences. So you work out, for instance, what is negative 13 subtract negative 10. The answer is negative 3. And negative 16 subtract negative 13, I think is also negative 3. Then negative 19 subtract negative 16, you get negative 3. So we call it a constant difference because we are getting the same number all the time. So we know that D is equal to negative 3. So now we can find Tn. To get Tn, we can use the formula A plus n minus 1 multiplied by D. You can use any other formula that you know, even the formula that is suggested in your book. But in this case, what is A equal to? A is negative 10. And what is, obviously, n should remain there because we are looking for the nth term. So it has to be in terms of n. And what is the difference? The difference is minus 3. Do you see why I'm putting it inside a bracket? You can imagine if that negative 3 is not inside a bracket, it will then look like you are saying n minus 1 subtract 3, right? And I think the best thing is to then move your D to the front if you don't want to confuse yourself. So you can move that negative 3 and bring it in front of n minus 1. But if you won't get yourself confused, just leave it there and multiply. So what is negative 3 multiplied by n? Minus 3n. And what is minus 3 multiplied by minus 1? That's a plus 3. Simplify that and maybe start with your term in n. So it's minus 3n. What is minus 10 plus 3? Minus 7. So the general term is given by negative 3n minus 7. If Tn is equal to minus 3n minus 7, then what is T20?
67.
You just substitute for n, you put 20, right? So this is minus 3 multiplied by 20 minus 7. Do you say minus 67? Okay. This is another question. Which term has a value of minus 307? Which one? It's the 100th term. Okay, so first you need to understand the question. People make mistakes here, and they substitute, like they replace n with negative 307, right? So you need to understand we are looking for the position of a term whose value is minus 307. So how do we answer this question? Because you are not just going to give me the answer. Right, we're going to say we are given here that Tn is equal to minus 307. But we know Tn is minus 3n minus 7. So minus 3n minus 7 is equal to minus 307. So I need to see that equation. And then you solve that equation for n. So minus 3n should be equal to, what is minus 307 plus 7? Minus 300. That will be equal to minus 300. And therefore n must be equal to 100. So it means T100 is equal to minus 307.